This question 8, is about structure and bonding. Draw a diagram to show the strongest type of interaction between two molecules of ethanol. Well, I've got an O to an H, so when I've got an O to an H, or an N to an H, or an F to an H, then the O, the N, and the F are very, very much more electronegative than the hydrogen. So you get large delta plus and delta minuses, large polar bonds within the molecule, and therefore the delta plus and the delta minuses attract each other across between different molecules. And it's actually the lone pairs of electrons on the oxygen attracting the delta plus that cause the hydrogen bonding, as well as the delta minus as well on the oxygen. So the oxygen's got a delta minus, and it's also got lone pairs of electrons. And so you've got to draw the shape of the molecule, and you've got to draw two molecules with intermolecular hydrogen bonding, and you've got to draw it in the correct shape. Quite a tricky thing to do for 3 marks. So let's have a look how that works. So first of all, you've got to realize that the shape of CH3CH2OH, you can forget about this part. You can put CH2CH3 if you want to, or C2H5. It's CH3CH2, and then I've got an O and an H, and an oxygen has got 6 electrons in its outer shell. It's in group 6, so it's got 2 as a lone pair, another 2 as a lone pair, and then 1 in each of the 2 bonding pairs. So it's a V-shaped molecule here, similar, I suppose, to water. So that V-shaped molecule, you've got to draw 2 V-shaped molecules, and you've got to draw the lone pairs on them. You can either draw them as lobe, these sort of pear-shaped sort of bubbles if you want, or you can put 2 dots, 2 pairs of 2 dots. Either way, but you've got to show this shape. You've got to show, therefore, between the delta plus and the delta minus, or the lone pair, as this. So this has got a delta minus and lone pairs as well between the delta plus and on the H and a lone pair, and you've got to show that as a dotted line, because that's an intermolecular attraction, an intermolecular hydrogen bond between the two. And you've also got to draw in a straight line the O, the H, and the O, and another H out here. So it goes H, O, H, O, because these lone pairs and the H plus and the lone pair and the H plus all repel, and therefore set it up in a line. So you can see from the mark scheme how it works out. You've got 2 lone pairs on each oxygen atom, and delta plus and delta minus on the OH bonds. That gets you a mark. The second mark is for showing the intermolecular hydrogen bond as a double dotted line in between the H plus and a lone pair of electrons, or a delta minus on the on another molecule as an intermolecular bond, and then have the alignment O to H to O to H in a straight line for the 3rd mark. Methoxymethane is a methyl group and then an oxygen bonded to another CH3, so it's C with 3 H's and O bonded to a C that's got 3 H's as well, and then I've got ethanol. So in terms of intermolecular forces, explain the difference between the boiling points. Well, you've got very strong hydrogen bonds in ethanol, so you've got an O bonded to an H, so you've got strong hydrogen bonds, therefore strong intermolecular bonds and a high boiling point, whereas methoxymethane has only got dipole-dipole attraction. So you have got some delta plus and delta minuses between the O and the C. The O is much more electronegative than the C, but the delta plus and delta minuses are not as large as in hydrogen bonding. So hydrogen bonding, large boiling point, strong intermolecular forces, and the hydrogen bonds are stronger intermolecular forces than the dipole-dipole attractions that are in methoxymethane. Draw the shape of POCl3 molecule in the shape of ClF-, so and suggest bond angles. So phosphorus is in group 5, so it's got 5 electrons in its outer shell. Oxygen's in group 6. Now oxygen wants to gain 2, so it's going to put 2 into a covalent bond and take 2 from the phosphorus into a double covalent bond. So the oxygen will put 2 into the covalent bond and expect the phosphorus to put 2 into the covalent bond. So that means phosphorus had 5, it's put 2 into the P to O double bond, and it's got 3 left over, so it's got 3 Cl's bonding those 3 remaining electrons. So it's got 4 bonds and no lone pairs. 4 bonds and 4 lone pairs is going to be a tetrahedral shape. It will be slightly distorted. It won't be 109.5. These three will be pushed slightly closer together because you've got more electrons here. You've got 4 electrons in this double bond, which will create an extra repulsion. But you get the marks for saying that it's a tetrahedral shape. That's fine. ClF minus, ClF4 minus rather. Chlorine is in group 7. It's got an extra electron, so chlorine is the single atom that's in the centre of the molecule. It's got 7 electrons in its outer shell. It's got an 8 there because it's got a minus, so it's got 8 in its outer shell. It's got 4 bonding pairs, so 4 of its 8 electrons are involved in 4 bonding pairs, and therefore it's got 4 left over. It's got 2 lone pairs. That due to electron pair repulsion theory says that all electrons repel as far apart as possible, and the repulsion between lone pair and lone pair is stronger than the repulsion between lone pair bonding pair, which is stronger than the repulsion between bonding pair and bonding pair. So the 2 lone pairs will go as far apart as possible. They'll go up and down, and the 4 bonding pairs will then be in a square planar shape around it. So the 2 lone pairs up and down as far away as possible, and the 4 bonding pairs then in a planar shape at 90 degrees from each other. You call it square planar shape, remember, because you don't you use the lone pairs to calculate the shape, but actually when you name the shape you only use the bonding pairs to name the shape, so it's square planar rather than octahedral. You ignore the lone pairs when you describe the shape. The name of the POCl3 is a tetrahedral, a distorted tetrahedral. Tetrahedral gets you the marks. ClF4 minus is a square planar shape. Bond angle in ClF4 minus is 90 degrees between the ClF bond and the next ClF bond is 90 degrees here.